So this is me, breaking into my own house, sneaking up the stairs with full intent to steal my own precious jewels and finest cutlery from under my own nose. But wait!
Intruder alert! Intruder alert! Intruder alert!
Not so fast, other me. I see you. I've got an email notification alerting me of your presence. I'm calling the police. Hello, officer. All in a day's work for my handy-dandy laser tripwire powered by a Raspberry Pi. Huh. Eat it, Tom Cruise. And guess what? That's exactly what we're going to build in today's video. Let's have some fun. So to make this feat of engineering happen, we need some materials to get started. First off, a Raspberry Pi, and as mentioned in previous videos, I have a Raspberry Pi Model 3 B+, but any of them will do. I used this electronic starter kit for the Raspberry Pi that has a bunch of cool projects to learn electronics, Python, and C programming. There are a couple different ones on Amazon, but this brand is called Freenove, and I highly recommend. It also happens to have everything that we need for this build. So you'll need a breadboard with GPIO cable. So GPIO is a set of general purpose input-output pins that can send and receive electronic signals. And this is how we interface with our Raspberry Pi board. You'll need a 1UF capacitor, a light-dependent resistor, LDR, 3 pin-to-pin jumper leads, and 2 socket-to-pin jumper leads. And then outside of the kit, you'll need a laser pointer. I picked up a cheap one on Amazon. It even has some fun shapes for playing with your pet. Or yourself. Sorry. And finally, a drinking straw. So I'm sure you're wondering why the heck we need a drinking straw. Well, this is a simple little hack to shield the light-dependent resistor and to focus the laser beam at it. So let's get this puppy assembled. You'll need to connect the one end of the LDR to 3.3 volt power, and then the other to the GPIO pin that you plan to target in your program. For mine, I used GPIO 17. Also, just a quick note, I'm still learning all this stuff myself, and I'm by no means an expert. That's why I initially got the starter kit. So if you have any suggestions or ways you think that I could do things better, please let me know. So we'll connect our capacitor to the ground and then the other end between the LDR and the GPIO pin. I also think I'm going to use 2 more jumper leads to allow the LDR to bend away from the breadboard. This will help when we assemble all of this into a box. And that's basically it. Here's a top-down image of how I set mine up. So now we just need to connect the GPIO cable to our Raspberry Pi. Now be careful when you plug and unplug this, as you can bend the pins on the Raspberry Pi if you're not careful. So now we need to write a simple Python program that will detect if the laser beam is broken by an object or a person. So I'm going to set this up on my local machine first, and then I'll show you how to remote into the Raspberry Pi and copy our code so it can run there. Alright, so we're going to set up our simple Python program. I created a new file, called it main.py, and I saved it in a folder called intruder alert. And so this is going to be really simple. We're going to have 3 lines. So from GPIO 0, so that's the library for GPIO, we're going to import the light sensor module. Okay, so then we have the light sensor, and then LDR, which is the light resistor. LDR equals light sensor, and then we're using the GPIO 17 pin. So LDR equals light sensor 17, and then LDR dot when underscore dark, which means whenever the light, there's no more light, that is going to equal, and then we're going to use a lambda function, which is a simple kind of a function in Python that if you only have a very simple expression, usually one line, it allows it to run. So lambda, and then we're going to print out intruder alert. Oops, let's do all caps. Intruder alert. There we go. All right, and that is all we need to make sure that all the components are set up correctly and to test to see if it prints to the console whenever we run it. So now we can copy this code from our editor to the Raspberry Pi. The easiest way to connect to a Raspberry Pi from another machine on your network is by using VNC Viewer. So we can enable access in the Raspberry Pi settings and then download the software onto our machine. So this is supported by the Raspbian OS by default, and all that we need to do is put in our IP of the Raspberry Pi to connect. Then we log in. This makes it much easier to work with these kinds of electronics projects so you don't have to connect the Pi to an external monitor. So now that we are logged into our Raspberry Pi, we're going to make this super simple. We're actually going to use the Python interpreter for this. So Python 3. And then we're just going to copy and paste each of our lines into the interpreter and run them as is. So first we'll do our import of the library and the module. Paste that in, run that. Then we assign LDR to the light sensor. Paste that in. Okay, and now we go over to our setup and test it out. So next, I want to kick things up a notch and send an email notification to my phone when the laser is tripped. So note, there are many tutorials online to set this up using Gmail's SMTP servers. I unfortunately went down this route in the beginning. I set up the code, I set up a brand spanking new Gmail account, only to find that Gmail accounts no longer support SMTP for security reasons. Fantastic. So you can set up your own local SMTP server, but I think it's much easier to just use a service like MailerSend or Twilio, which have super simple APIs to make this happen. Most are paid, but MailerSend has a free account that allows for 3,000 emails sent each month. For tinkering purposes, this works great. Okay, so for adding the email notification functionality, we're gonna set a new file in our intruder alert folder. I'm just gonna call it send email.py. And so then we're gonna actually trigger this script within our main.py whenever the beam is cut. And then this will send the email to our phone or to our computer, whichever you like. And for this, I'm actually pulling right from the MailerSend API. This is kind of what they have laid out in their documentation. So basically we are importing the MailerSend library and importing emails. And then we have to set up our API key, which I can show as well. And this script basically just sets up the mail from, the recipients, the reply to, and then we set the mail body and for the email and what we want the subject to be. So I have it as intruder alert, and then the actual HTML content that will show for the email. So there's an intruder called 911, and then the plain text content as well. So I actually got this script right from the MailerSend developer site, and we are using Python. You do have to make sure that you first install MailerSend within Python. So right down here, Python, you'll use the pip installer. So you'll copy this and install it, which I've already done. And then it gives a couple examples of some very simple explicit declarations. So this is kind of sets up the whole structure, and you'll put in your API key, which you can set up through the MailerSend website. So now we need to integrate the MailerSend API and trigger the Python script to run. So then we will need to change our main.py so that it does the same thing as before. It's importing the GPIO0 library, importing light sensor. Now we're going to use the time library as well and import the sleep module. And then we're importing subprocess, which is basically what allows us to run a different Python script from within our main.py. Same thing with setting up the LDR to be the light sensor GPIO 17. And then we're setting up a while loop. So while it's true, we're going to wait 0.1 seconds. And then if the LDR value is less than 0.5, so basically it becomes dark, we're going to run that next send email Python function, or Python script, I guess I would say. And we're also going to print intruder alert as we did before. Then we're going to wait, and then if that doesn't happen, otherwise the system is going to be armed and ready to receive input and ready to send that other script. Okay, for the final setup, got a nice inconspicuous Amazon box here. We're going to put all the components inside and then be able to hide it so that somewhere where we come up the steps and step on it, they'll be triggered. Hope everything fits in here. Looks like it will. We'll need to cut a hole in the side of this box for the straw. A knife! Okay. Let's see. Right in the O or the I. Should work. That ought to work. Still connected. close her up. Take this guy, set it down on the floor. Take our laser. Okay, we got our laser on this side. And I walk over. It's going into the box. So here are the steps. So first, the system is armed. The intruder trips the beam. The program prints intruder alert. The program sends an email notification. And the program waits 8 seconds. And then the system is armed again. So with this build, you have a simple DIY alert system using a cheap laser pointer and a Raspberry Pi. So there are a bunch of different directions that you could take this from here. So you could add a buzzer or speaker to make noise when the laser is tripped. You could set off a light show to really get the party started. Or you could trigger a remote servo that fires a taser and brings the pain to any petty thief. The options are endless, and now all you gotta do is go out and build one yourself. And of course, I'll leave all the links and the resources that I used in the description down below. And if you have any questions, don't hesitate to ask in the comments. If you enjoyed the video, hit the like button and subscribe. It helps out the channel, and I greatly appreciate it. Thanks so much for watching. Take care.